Hi, my name's Sasha Moore, and I'm delighted to be moderating today's Legal Update, an initiative from Unisearch, Australia's leading and most established provider of expert opinion services. This program has been created to provide bite-sized updates on various matter areas to help keep the profession informed about topical developments, legislative updates, and changes in respective fields. Welcome and thank you for joining us. In today's discussion, we're going to draw upon the insights from one of Unisearch's esteemed experts, Professor Nasser Kahali, Head of School of Civil and Environmental Engineering at the University of New South Wales. Professor Kahili is a leading specialist in geotechnical and civil engineering, soil mechanics, and computer generational geometrics. Professor Kahili has played a key role in many projects of national importance across Australia and regularly acts as an expert witness in court, assisting cases relating to geotechnical engineering. In this discussion, we're going to explore the hidden complexity beneath many high-value construction failures and disputes, including why geotechnical issues are so frequently at the centre of complex construction and infrastructure disputes, how changing ground conditions alter project risk and potential legal exposure, the indicators lawyers look for when they're assessing whether a dispute may involve a geotechnical causation, and practical considerations for lawyers briefing and working with geotechnical experts. Welcome, Professor.
Thank you very much, Sasha. Thank you for that kind introduction, and I'm delighted to be part of this interview.
Oh, thank you. Well, we can't wait to hear your insights. But before we delve into it, we're also joined here today by Unisearch's Business Development Manager, Christopher Aaron Yong. Christopher will provide his perspective from a bird's eye view across multiple matters on what broader patterns are emerging. Welcome, Christopher.
Thanks for having me, Sasha.
As always. So let's get started. Nasser, why are geotechnical issues so frequently at the centre of complex construction and infrastructure disputes?
Sure. I mean, this is the $64 million question. And to address it properly, I think it would be useful if I just go through the process of design and construction in any engineering field. Typically, for the purpose of design, we're dealing with a material, and we need to characterize that material in terms of strength, deformability, and engineering properties. Depending on how complex that characterization is and how complex the material behavior is and how much control we have on those sort of engineering properties, it would translate to the complexity of the design. So the simpler the material, simpler the design approach, and greater predictability. Just as an example, in many civil engineering sort of projects, we deal with concrete as an example. Concrete is a very well-defined sort of material, engineering material. I call these made materials. We make them, they are not natural materials. And because of that, we can make concrete to absolute specification, to have a certain strength, to have a certain permeability. We can control its weight. We can control its chemical composition to suit a chemically aggressive environment. And we also have straightforward approaches to its characterization. So not only we have control, we can characterize these properties very efficiently. And as a result, the engineering approach for its design is quite straightforward, and we have a great level of predictability of the behavior once it's designed and constructed. The same thing applies to other materials like steel and timber. So when we have that sort of predictability, typically design lends itself to having a code of practice. So experienced engineers, committee members, they come up with a code of practice. We have Australian standards that tells you if you're designing a concrete structure, what steps to follow exactly. How to mix design, how to prepare the concrete, how to look at different sort of joints and interactions between beam, column, slab, and so forth. Every aspect of the detail specified. So when we have a litigation with a sort of concrete structure, it's quite straightforward. We'll go and see if the design complies with the code of practice, whether the construction and workmanship complies with the relevant codes of practice, and very easy to identify what has gone wrong and perhaps who's liable for the less than satisfactory performance of the structure. The same thing applies to steel and timber. When it comes to geotechnical engineering, we deal with soil as an engineering material. Soil is highly variable and extremely complex to characterize. We are not dealing with a single type of material. Steel is a single type material manufactured to this specification. Soil is a natural material. For example, each grain could have a separate, different mineralogy. We can have a complex pore structure, and that pore space can be filled with air and water to different degrees. For example, a same soil, when it's dry, has a very different properties, engineering properties, than when it is wet or partially wet. So inherently very complex. So if we take a sample of soil and take it to the laboratory, we need specialized equipment and highly experienced technicians to be able to interpret the observations in the laboratory and lead them or translate them to engineering properties. Even when we characterize these to the perfection, soil is highly variable in the field. So the soil samples that I've taken from this location, if I go 1 meter to either side, the direction, the soil property will be very different. This variability, this complexity leads to very complex design processes. And there are no similar geotechnical engineering designs and problems. So every design should be handled from first principles for the specifics of that sort of project. Because of this, we cannot have a code of practice in geotechnical engineering, and we don't have a code of practice in geotechnical engineering. You cannot put it into a prescriptive approach to design. And that is the case globally. So every design is unique, and there are differences of opinion. So this lends itself to innovation in the field and differences of opinion. And these differences of opinion are celebrated. You can have, for the same problem, different designs, and both of them works. So when they work, it's fine. But when they don't work, differences of opinions lead to disputes, and disputes require experts' opinions to clarify the fog, to clarify the confusion, and perhaps demonstrate what sequence of events, what assumptions have led to the less than satisfactory performance in the field.
Well, thank you for that overview. It sounds extremely multidimensional, to say the least. So let's maybe delve into sort of that next layer down. So could you give a bit more clarity in terms of how do changing ground conditions alter project risk and potential legal exposure?
Fantastic question. Variability is part and parcel of geotechnical engineering. No matter how much we try, the ground condition is assessed at discrete points, let's say at intervals of 50 meters. So we don't have a definitive understanding of the ground condition between the points that we sort of characterize the ground condition. So always there are assumptions involved in this sort of ground condition, and those assumptions form the basis of the design. So design is based on those assumptions, and it will work if those assumptions are correct in the field. So we tackle this problem through what is called observational approach, so that during the construction, constantly you have to observe the ground condition that you're encountering, check it against the assumptions made in the sort of design, and if there are significant variations, you need to alert the designer and modify the design to suit the ground conditions that you're dealing with.
Okay, thank you. And I know that in our offline discussions, you were talking about the concept of design life and the assumptions that can be made within that parameter. Can you provide a bit more context on that?
Yes, every structure that we design has a design life, and that design life is controlled by sort of potential degradation of the properties of the material. Like concrete will degrade with time, steel will corrode with time. For example, if you're dealing with a port, with a terminal in an aggressive environment, gradually the support system will rust. And we know exactly how that rust will progress. So when you're designing, given the chemistry of the environment, you know what is the capacity of this thing after 50 years or 100 years, and that controls the design life of the project. But at any stage, if we go and look at that structure and we see the level of degradation, we know exactly at what stage of degradation it is and what is the remaining service life of that structure. This is in terms of degradation. There are some designs that are not susceptible to degradation that much if you look at all the extreme conditions. In those situations, the design life is controlled by extreme events. For example, if you're designing a dam, the design life of the dam is controlled by the design flood. We have a regular occurrence of different flood events, and you say that, okay, the design life has a 1 in 10,000 sort of recurrence, and I want to have 10% probability of that happening during the design of the project, and that controls the design intervals that you're sort of coming up for your project. Or the same thing applies to earthquakes and so on.
Thank you. And could you also just give a bit more clarity in terms of the safety factors and how they're measured?
Yes, geotechnical engineering, the design process is very complex. Often we assume simplified approaches. There is uncertainty and sort of associated with those designs, and also material property is highly variable. In order to take into account those variabilities, we always have a margin of safety embedded in our design. So we don't design a structure to its full assumed capacity. We know that this may not be the case in the field, so we have a margin against failure. For example, we define this using a safety factor. In geotechnical engineering, for permanent structures, we have a safety factor of 1.5. So we assume a reserve capacity of 50%. For temporary structures, we have a a safety factor of 1.3, which is the 30% reserve capacity for a short term.
Great, thank you. So let's move on to what technical issues are commonly misunderstood in geotechnical litigation.
Amongst the experts, the fundamental sort of knowledge of how soil behaves. So often, as I said, we assume simplified approaches to soil behavior, and we use them in sort of design of geo infrastructure. Often they're reasonable with the margin of safety that we have for the purpose of design. But if you're trying to see in reality during service how structure has behaved leading to the failure, you need to know the actual behavior of the soil, and that actual behavior is extremely complex, and it's very different from the simplified approaches that you have used during the course of the design. That is a main area that, whether it's in the court cases or amongst the experts, we have a deficiency and lack of knowledge.
Thank you. So as it relates to the profession, what indicators should lawyers look for when assessing whether a dispute may involve a geotechnical causation?
Most of the civil engineering sort of litigation cases have their roots in geotechnical engineering, because whenever you design a structure, whether it's concrete or steel, they have to transfer the load into the ground. They can't suspend in the air. And when they are transferring the load in the ground, we're dealing with foundations. And if there is excessive settlement, then that is a geotechnical engineering litigation. So whenever issue is related to the foundation and support, any excavation, tunneling, dams, roads, highways, embankments, natural or made, these are cases that involve geotechnical engineering.
And the breadth is quite extraordinary. So we were just talking offline that, as you mentioned, excavation, tunneling, and so forth, but it also spans to major infrastructure, airports, bridges, etc. But also conversely, in the residential side of things, whether they're big towers or communities and town planning and so forth. So it really spans across that residential, industrial, and commercial landscape. So the implications are so far-reaching.
Absolutely. We had a number of high-profile cases involving towers in Sydney, one in Mascot, one Opal Tower. One of them certainly, the issue was related to geotechnical engineering aspects of the project. Opal Tower initially, suspicion was leaning towards the foundation problem, but when we looked at the settlement profile, it was quite clear that it was the construction issue of the towers.
Indeed. So, what are some practical considerations for lawyers briefing and working with geotechnical experts?
Um, some of the difficulties that I have seen in my uh, interactions with lawyers is that typically the instructions that you receive, they are not specific enough to the project, and they are not addressing issues that are ambiguous and can help the court with understanding the factors contributing to what is observed. An example, in in a recent case, I received a set of instructions to express my opinion on. They were so generic that I was thinking that I don't even need to know the details of the case. I can just answer these questions without knowing anything about the project. Very generic. As an example, what happens if the design is not followed? Of course, it can lead to difficulties in the performance of the structure. So it is not specific enough. So it would be useful if legal team looks at the case that they're pursuing to see what are the gaps in their defense of the project and pose those questions to the expert in the field.
Great, thank you. So, moving on to some practical takeaways, Christopher, I'll segue to you. From a bird's eye view across multiple matters, what broader patterns are emerging in the sector?
Thanks, Sasha, and thank you, NASA, for your incredible insights. It's taken notes the whole way through. From a bird's eye view, it's becoming more apparent that the assumptions made at the beginning of a project, particularly geotechnical assumptions, continue to drive really significant legal consequences down the track. This is particularly important as New South Wales records its highest number of residential construction cases in 7 years, or residential construction builds in 7 years, and Victoria's transformative multi-decade major projects pipeline. From that practical perspective, savvy practitioners have always understood the importance of appropriately timed geotechnical assessments. But one thing that we're seeing emerge are the consequences from that design life lens. So, Sasha, you touched upon it about 2/3 in. So it's whether, as NASA said, the degradation of materials or the capacity to withstand extreme 1 in 10,000 events over time have actually been correctly mapped out. So if we were to extract one of NASA's great examples, if the original soil assumptions weren't properly tested, a structure's ability to perform for the design life is then compromised. And that's when the disputes will start to emerge. And then the parties will start to contest whether that structure was fit for purpose over its intended life, whether it's 50 years or more, and whether duties of care are breached. And like we've seen this dynamic play out in several matters historically, one of which NASA has appeared in as an expert witness, and that's CH2M and the state of New South Wales back in 2012 in the Supreme Court, and that's 693. And more recently, the consequences of inadequate understandings of these risks have unfortunately culminated in the devastating Macrae landslide. And over several months, 40.3 million litres of water was infiltrating a slope in the Mornington Peninsula. To put that in perspective, I believe that's around 16 Olympic-sized swimming pools. And that ultimately caused a landslide which destroyed homes, displaced families, and inflicted significant psychological and emotional harm. And while the Board of Inquiry acknowledged the causes of landslides are complex, the 30 resulting recommendations really illustrate how technical misjudgments can cascade into wide-ranging legal, social, and communal ramifications. I'll just go into two more things quickly. Looking forward, this pattern which NASA has called out will continue to emerge in different domains. So two things we've talked about, traditional private and public construction activities, where excavation, shoring, installation, or the accuracy of soil profiles and environmental conditions are fundamental to performance and safety. That's really important there. But then also modular and prefabricated houses. So Sasha, we talked about this earlier when we interviewed David Lyons, the UniSearch expert, where these modular or prefabricated homes might be designed in one geotechnical context, but then installed on top of another. And because of these differences in underlying assumptions, the performance gaps and the subsequent consequences for purchasers, builders, subcontractors, and insurers quickly materialize. And of course, from that insurance lens, there are public liability exposures, coverage considerations for insured, and even some coverage disputes emerging out of this. And finally, from that expert evidence perspective, as NASA touched upon, I think those foundational principles really remain unchanged. So really clear swim lanes, precise letters of instructions, and strict technical boundaries are really, really important, and they continue to be important. And our pragmatic clients often engage the UniSearch experts within these specific domains, whether it's groundwater, surface water, slope stability, and these experts avoid straying into adjacent fields. And the ability of our experts to be able to set these boundaries is really critical, particularly as matters become more complex and interdisciplinary across different scientific areas. And just quickly on shadow experts, the principles in Justice Reardon's 2019 Oswald judgment continue to be really informative for practitioners. So shadow experts or those types of experts might be engaged by firms to advocate for a client's interests, be involved in strategic decisions as to how independent experts should be briefed, and they can inform lawyers on technical matters. And that's the 2019 Oswald judgment. So bringing this all together, as Australia starts to witness and live through increasing levels of major projects and residential builds, and the disputes that come from these complex and interconnected builds, the foundations of expert evidence play a critical role. And early engagement at the right stage is very, very important.
Tremendous. Thank you, Chris. So we'll have to cover it off now, but we could talk about this all day long. Thank you so much for your tremendous insights, Professor Kahili. We appreciate your assessment of the complex geotechnical issues that frequently underpin major construction and infrastructure disputes, including the interaction between ground conditions, engineering assumptions, causation, risk, and legal exposure. Your practical insights into identifying geotechnical indicators in litigation and effectively working with technical experts have provided valuable guidance for practitioners navigating these increasingly sophisticated matters. And thank you, Christopher, for those valuable and very practical insights and commentary and broader industry observations and your perspectives on the increasingly complex geotechnical dispute, including the growing importance of design life consideration and the intersection between geotechnical assumptions, insurance exposure, and legal risk has provided some important context for practitioners. We also appreciate your insights into the evolving role of expert evidence, particularly the importance of clear expert boundaries, strategic engagement of technical specialists, and the multidisciplinary nature of modern construction and infrastructure disputes. And to those who have tuned in today, we hope you found this session insightful. If you'd like to reach out to UniSearch to discuss a matter, you can email Christopher at c.yong@unisearch.com.au. Until next time, goodbye.